Hello, this video is an explanation on how you convert a regular expression into an NFA, so a non-deterministic finite state acceptor. So what I'm going to use is McNaughton-Yamada-Thompson algorithm, where it defines a couple of patterns, and you use these patterns to build up bigger and bigger and more complex regular expressions. So the first pattern is the epsilon, which is the empty case. So with one state, you can go with an epsilon to another finishing state. Then you have a pattern A, so it can be anything, any character, anything really. So from one state, it can go and have anything, and it finishes. So for example, if I have a regular expression that is simply 1, then it would be starting state, 1, ending state. Then we have the pattern AB, which is A concatenated B. So it would be the pattern for A. So it would be the pattern for A with epsilon. And the pattern for B. So we can use the pattern for A and the pattern of B, because it's a simple except one character. And B, finish. And then we have the pattern A or B. So we'll use the pattern for A, which is A. But A or B has a special pattern where it diverges into 2 epsilons. And then you can say A, B. Sorry, apologies. We're trying to use patterns here. So what I'm going to do is here, I'm going to call this the pattern for A. Then I'm going to call this the pattern for B. Then I'm going to say with epsilon. So I'm actually going to go back. One more. There we go. So A, B. So the pattern for A would be this. The pattern for B would be this. And then the OR here has to have this kind of shape. And then this is our finishing state. Then we have a pattern called star, so A star. A star would be starting state with epsilon, followed by A pattern. So A can actually be entirety of this. It can be this. It can be this. This can turn into A. So it's the shape. So AB is now A. And then we just use this pattern to build upon other patterns. So this A can basically be any regular expression. That's what I mean by it can be anything. So it can be any combination of regular expressions. Star. So A star says A, it can go to epsilon, but then it can go to a new state, the finishing state. So these are 1, 2, 3, 4, 5. These are the 5 patterns for making regular expressions. So if I have a regular expression like 1 or star 1, so this is 1 or 0, 1 and or 0, with any combination, so it doesn't even have to exist, and there must be a 1 at the end. So mathematically it's for the elements 1 and 0, it must end, so 1 with 0, it must end with 1. So basically it is a binary number. So 1s and 0 are binary numbers. So it's a binary number that is odd. So a number that is not divisible by 2. So for example, 1 0 1 1 would be 8 and 3. So 8 plus 3 equals 11. So this is accepted by our finite state. So what does our finite state machine accept? It accepts 1, 0, 1, which is the same thing as 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1. So this is 1, 2, 3, 4, 5, 6, 7. So it accepts odd numbers, I'm pretty sure. I might be wrong, but the focus is how could we draw this? Well, we start with the simplest possibility. We try to make the pattern for 1. So let's just look at 1 and let's try make a regular expression for 1. So we look at this. Turn into NFA. So we look at 1 over here. And 1 can be, you can use the pattern for A, which is starting state. With 1, it goes to a finishing state. Then let's look at 0. So 0 is the pattern 0, then it goes to a finishing state. Then let's combine both of these, 1 or 0, and use this pattern. So instead of A, it'll be 1, instead of B, it'll be 0. And the pattern for A will be this pattern. The pattern for B, which is 0, will be this pattern. So we'll build upon it we build upon the regular expressions because A and B are regular expressions themselves. So 1 or 0 would be starting state followed by epsilon. Then we use the pattern for A, which is simply this, 1. And it does not finish, actually, my bad. It goes 1, then it will have to join back. 0. And epsilon finishing. So we're just using this pattern. The regular expression A comes from here. So this entire thing is our regular expression A. And then this is our regular expression B. And we just substitute the regular expressions, and then we have this. So now we do 1 or 0 star, which is A is now this regular expression. This whole regular expression becomes A. And then we're just going to use the little pattern for A star, which is starting state epsilon followed by this whole pattern, epsilon, 1, 0. And remember, epsilon is just the empty character, so it's basically nothing. So it's the lack of a character. And it is, we're just copying this pattern and we're putting it into this pattern. Our regular expression A is 1 or 0. and we're just substituting everything here. So this will now come here with epsilon. So from A, from the ending of A, it'll go to the start. And then from the start, it can go all the way to the end, to a finishing state with epsilon. My bad, I forgot to add epsilon here. Let me just double check. Okay, yeah, everything's right. So epsilon, epsilon. So this is 1 or 0 star. Did you see how it doesn't actually require much thought? All we're doing is we're just substituting the regular expressions, the previous regular expression, to make bigger regular expressions. So let me scroll down just a little bit. We can actually ignore the first case. It's not that useful. Then we have A. So we have these things. Now we have to just finish up, which is 1 or 0 star 1, which is the regular expression we wanted to draw at the very start. So basically, it will be this whole regular expression becomes is going to be, we're going to use this basically. So I guess you can put A here. I guess you can do A followed by 1. So something like this. And this regular expression is this entire thing. Yeah, I mean, I guess this could be a little bit confusing. So I should really say this is a character. So I guess I should do lower character C, and then I'm gonna say A, and then A could be the empty set, which is just nothing. So refer to this. This is a better approach. And then you could use the C inside of every other combination. So let's just focus on this part. So that becomes, so we copy this whole diagram, which is, because what we're doing is actually just substituting 1, 0 in brackets star with A, followed by a character 1 finishing state. So it'd be bam, epsilon, 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 1, 0, epsilon, 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 it's not finishing anymore. So epsilon, followed by the character C, which is 1 in our case. 1, followed by finishing. And what I'm going to do is, since I already drew this whole thing, I'm just going to name all the states now. A, B, C, D, E, F, G, H, and I. So that's our NFA. So NFA. And then in the next video, I'll talk about how you convert an NFA, such as this one, into a DFA. Thank you for watching.